Okay, so today we're going to talk about the scientific method cheat sheet. Originally, like if we were in class, we would just do all this in one day, but that would be kind of a really long video to sit and watch in one for one class or you're online. So what I'm going to do is I'm going to split this up. So I'm going to talk about what is the scientific method all the way through hypothesis in this video. The next video will just be the experiment, and the last video will be the conclusion through the reminder, just the rest of the page. So what I recommend is opening the video and the Cami app, the assignment, side by side in two separate windows. That way you can edit while you're watching the video. Don't don't try to remember this and then go back and do it. Just watch the video and edit while you're watching. So let's start out here. If you want to put your name, you can do a text box. Click here and put your name. You can change the font and all that stuff. So let's go ahead and start reading. What is the scientific method? The scientific method is a problem-solving tool used by scientists to test a hypothesis. In short, the scientific method is a process used to help figure out if what you're testing makes sense or not, scientifically speaking. There are actually many variations in the scientific method. We will learn and follow a short, easy-to-remember version. In fact, our method only has 4 basic steps. So, one reason I like to start out with the scientific method is whenever students come to me in 6th grade, they don't know the scientific method. They think that they know it. Some of them do, and some of them just have absolutely no clue. Very few actually know about the scientific method and know how it really works. This is actually one of the first lies I like to dispel when you come to me. So, the scientific method does not actually exist. The scientific method doesn't exist. There is not one set way to do science. That's what's so awesome about it. Math, 2 plus 2 always equals 4. And now there are laws, there are things that do happen in science no matter what, like gravity. But the way that you come to your conclusion, you can test in different ways. So, our scientific method, if you were like me, I learned like a 9 or 10 step scientific method when I was in grade school. And it was not until I got older that I realized that's actually not accurate. So I can't remember 9 or 10 steps. So the scientific method that I use has 4 steps. So they're listed right here: problem or question, hypothesis, experiment, and conclusion. So what we're going to do is we're going to click markup, and we're going to choose our highlighter and choose whatever color you want. I don't care. It's your paper. And we're going to highlight a few important things. So we want to know that the scientific method is a problem-solving tool that scientists use. So we're trying to figure out an answer to a problem. Also, it's a process. So we don't just go step by step, 1, 2, 3, 4, we're done. We may have to go back and edit. We may have to go back and retest. We may have to change our procedure. We may realize that our problem actually isn't a problem. Things like that. So we want to figure out if what we're testing makes sense or not. There are many variations in the scientific method. Remember, there's not just one. So ours has 4 steps. We're going to look again in this video at the problem and the hypothesis really quickly. So the problem or the question. This is where it all begins. You think of something that you want to figure out in a testable way. We're going to highlight that. Usually you come up with a question, such as, do seeds need light to sprout? Next, research your question. That's important for a problem. Make sure that you are using credible websites, not Wikipedia. So, I like to put problem or question because the problem should be written as a question. That makes more sense. You know what you're doing. You're answering that question. You're figuring out the answer to that problem. It has to be testable, though. If you can't test it, you can't do it in science. So that's important. You research your question because you don't just want to go in completely blind. You may see some proposed solutions. You may see some experiments you want to try or tweak. So you need to research your question, know what you're talking about, and use credible websites. Not just websites, but TV shows, videos on YouTube, whatever. Credible means typically when you're writing for any kind of subject in school, don't use Wikipedia, because anybody can go in there and edit that. So you may or may not be getting accurate information. So try not to use that. don't use it in science or any other research paper you write for Miss McCoy or anything else beyond Robinson too. So hypothesis. Once you have determined what you want to test and that it is testable, which is found by your research, then you come up with what you think will happen or a proposed solution to your problem. This is called forming a hypothesis or an educated guess. I'm sure you have probably heard, hopefully, that a hypothesis is an educated guess. Your hypothesis should be, this is very important, short, sweet, to the point, and measurable. In science, if it isn't measurable, it can't be done. So you want to get certain results. You want to be able to measure what happened, not just, oh, it changed into a pretty color. You need to be able to say, I think that the substance will turn from red to blue. So, very important. Your hypothesis may or may not line up with your ending conclusion, and that is okay. Never change your hypothesis to match your findings. If your hypothesis does not match up with what actually happens, take this opportunity to learn. You can't learn if you're always right. So, a few things we need to talk about here. Very important, a hypothesis should not be 28 sentences long. It should be short, sweet, to the point, measurable. It should be concise. It should be in a little paragraph, no more than 5 sentences. And then also here, it may or may not line up with your ending conclusion. Don't change your hypothesis. That is perfectly fine. You may, 100% of the time, your hypothesis might match your conclusion. But, you may 0% of the time, your hypothesis may match your conclusion. And either one of those scenarios are okay. The point is to learn. The point is this is what I think is going to happen. I did the experiment. Here's actually what happened. So if your hypothesis does not match up with what you find at the end of an experiment, ever, from in my class beyond, don't ever go back and change it. Okay? We want to see how you have learned. We want to see how your thought process has changed. So this is important right here. This is a life lesson, the first life lesson from me, of many. I like to throw those in there. You can't learn if you're always right. If you never, ever, ever miss a question on a test, you never miss a question on some kind of worksheet, then you can't learn. I can't teach you anything. So it's okay if you're wrong, okay? And it's okay if you have never been wrong in any class up until this point, and in this class it's the first time you've ever been wrong. That's okay, all right? You're here to learn. That's the reason I'm here. I'm not always right. I'll say crazy stuff a lot. I may write something, spell it wrong, anything like that. You're not always right, and that's okay, all right? Don't freak out if you mess up or if you get something wrong, okay? That way you can learn. So that'll be the end of this video. Make sure you have everything highlighted. That should be highlighted. You can look back through here. You can also go to the end of the assignment, the material. There is a completed PDF filled out the way you should have it filled out. Make sure that you have all of this highlighted, okay? Thank you, guys.